Hello, everybody. Welcome to our first webinar on the Green Webinar series that is dedicated to the airport domain. In this webinar, we're going to be talking about what the future is bringing for making airport operations more environmentally sustainable. So before getting into the matter, I have just next slide, please. So to tell you, we have 3 webinars coming up on this. This is the first one of the series, and we have 2 more in December, which will be for arrivals and departures on the 4th of December and almost just before Christmas for the en route. And this is the webinars you see at the top have already passed. All the webinars are later available on the SJU events page, together with the Q&A and the presentations available for download. So my name is Olivia Nunes. I work for the SJU. I have been with the SJU for 8 years. And before that, I was an air traffic controller in Spain. And we have a very, very full schedule today. So I don't want, without further ado, just to tell you, we welcome questions. These webinars aim to be as interactive as possible. As you will see, we have here a general chat, and then you have a questions tab. Please, if you have any questions, go ahead and post them on the questions tab, because the chat is very, very busy. And so if you post a question in the chat, it is very possible that we don't get to it. So questions, please, on the questions chat. The questions will be answered, some of them live, as much as we can. And then the rest will be answered in writing. Some speakers sometimes like to type replies while during the webinar. And if not, like I said, everything will be published afterwards. And next slide, please. So just today's speakers, I will be introducing each speaker before they speak, but just to give you an overview at the start, we will have Philippe Lene, who is the Aviation Sustainability Program Manager from the SJU. And after that, after his introduction, we will have 4 speakers digging into different aspects of the environmental solutions that are coming up to improve the situation at airports. So we'll have Sigrun Mattes from DLR talking about the trade-offs between airport noise, local air quality, and the impact of aviation on the climate. We will have 2 presentations on greener aircraft taxiing, one from Air France, Giuseppe Pilironi, and one from Schiphol Airport, where they have been working on this for a while, by Dirk Bresser. And then the last presentation is a bit the new kid on the block in the SESAR and in ATM. They're flying in the new intermodal or multimodal way, which is going to look at the impact on ATM and how ATM has to take into account and integrate the intermodal and multimodal point of view. Without further ado, I want to introduce our first speaker today. He will be Philippe Lene. We can close this presentation, please. Philippe Lene has very recently joined the SJU. He has been with us for 2 months. We're very, very happy to have him with us. Before that, he was an air traffic controller in France for about, I think, 7-8 years, and then he joined Eurocontrol. And then at Eurocontrol, he worked for many years as the network manager, taking different roles. And I think about 3 years ago, he was seconded to the European Commission to be in charge on the environmental aspects of aviation. So he's very experienced in this domain. He has been completely immersed into this for a few years. And like I said, he just joined the SJU. Philippe, please, the floor is yours.
Thank you, Olivia, and good afternoon, everyone. I hope you hear me well. It's okay?
We do.
Can you hear me, Olivia? Yes, it's excellent. So good afternoon. Yes. Nice to see all of you listening to this webinar this afternoon. After a series of webinars covering all the different aspects of SESAR JU role and responsibilities, it's time now to come back and focus on what is outside the current crisis context, certainly the greatest structural and vital change that aviation is facing at the moment, mitigate its environmental footprint. Aviation sustainability is central to all the debate, much more since 18 months. But aviation has not been standing still and has already improved many more since decades in all the different components from its sector, industrially, technically, operationally, and SESAR has been part of this improvement in its creation. The ICAO basket of measures suggests that until we fall into disruptive technologies, possibly around 2035, we must tap all our effort from its 4 pillars, and notably the air traffic management one. In this perspective, the SESAR JU role is therefore to move and come forward with solutions that will make from the European airspace the most efficient and environmentally friendly sky to fly in Europe. Climate impact mitigation is just not as simple as just acting on CO2 emission. The intention of these 3 webinars presented by Olivia is to invite you through a journey of a flight where we will aim mainly at 2 objectives. The first is to present you with a very large panel of projects that are concretely aiming at allowing ATM to reduce its environmental footprint in an inclusive and cost-effective manner. But we wish as well to highlight the fact that if we speak about climate action, one must consider the challenge to tackle at the same time the 4 main axes of improvement, namely the CO2, local air quality, noise, and the non-CO2 emission, and I include in that the contrails. So the perfect green flight is something difficult to reach, and we will show how the GU program is trying to understand and absorb all the different perspectives from the stakeholders, including, for example, the population living at the vicinity of airports. So thanks to be with us today. We are looking forward to your question. We are looking forward all this presentation, and I hand over back to Olivia now to listen to our presenter. Thank you.
Thank you, Philippe, for your introduction. So our next speaker is Sigrun Mattes. Sigrun comes from the scientific department, so she's actually diploma in physics, and she holds a PhD in meteorology from the University of Munich. She is currently part of the, she's currently part of the SESAR exploratory research community. She has over 20 years of experience in atmospheric impact modeling studies at DLR, the Institute for Atmospheric Physics in Oberpfaffen. Well, that's hopeless for me. And she currently works in, like I said, in a SESAR exploratory research project called Fly ATM4E. And she will be talking to us about both Fly ATM4E and the previous project that she coordinated, ATM4E. They are looking at eco-efficient trajectories, looking in particular at the non-CO2 impact of aviation.
Okay.
Sigrun, the floor is yours. Thank you.
Thank you, Olivia, for this nice introduction. So let's have a go with the Oberpfaffenhofen. You can just say OP. Okay, so I'm really happy to be here today. And in fact, I will be talking about these trade-offs between the airport air quality, the noise, and the climate impact. And as Olivia just said, I'm presenting work which is relating to an earlier project that we were having in terms of saying that aircraft operations, they are concerned by their environmental impacts, which are all 3: air quality, noise, and the climate impact. And just to see that this is a kind of long story, I'm showing here a bit of the Annex 16, where there's kind of 50 years of this annex. And in color coding, you can see like there is in green the noise, and then you have in blue the local air quality, and then you have the climate change. So this is where all these issues are coming up, and they have been coming up more in the recent years. So the current regulation and guidance documents, they address a certain number of issues, while from a scientific point of view, they are not covering all environmental impacts currently occurring. So for our understanding, it is desirable to assess the individual environmental impacts along the planned trajectory already during the optimization. So I'm just also showing here to give a bit of a flavor, like say, what is it when we talk about air quality? In fact, there are a lot of species which are regulated. There is sulfur dioxide, there's nitrogen oxide, there's carbon monoxide, there's ozone, and then there is another player in the game, which is in fact the particulate matter. And with the UFPs and the current issues on the health impacts arising, they are of growing concern in that domain. So, in fact, what we were set out to be doing in this ATM4E project, we were trying to integrate existing methodologies for the assessment of these environmental impacts in order to see what implication this has on environmental optimized flight operations. And in earlier studies, often also what you do for a certification, you have the information on the environmental impacts kind of offline from a comprehensive model calculation, which means you are doing a calculation once you have a full inventory, and then you see what is the impact in noise, what is the impact on air quality. However, our idea that we followed in this project was that we make available an information during the trajectory planning, which tells you to what extent the atmosphere is sensible to the emission you are doing there. And in order then you are enabled to assess the environmental impact, but also to mitigate it if you know you are flying in that region and there you have a large impact. And for this purpose, we developed a kind of method which allows the efficient integration of such environmental change functions, how we call them, via a metrological interface, like having an advanced service which tells you how sensible the atmosphere is. And I will be using this acronym, which is ECF, which we have also pushed further for have these kind of algorithmic ECFs, which allow you to use the MET forecast to generate them. So this is where we have been exploring the ideas for this concept. ATM4E was mainly in the initial phase dedicated to the climate impact, but then it was realized that all the issues should be treated in the same way. So it's important that you have the air quality and the noise dealt at the same time and not one after the other. So we had the idea to make such environmental impact information available along the trajectory as a MET data. So that would mean here's an illustration. You have two alternative trajectories. This is for a climate optimized route. And you want to tell which one is the route which has less impact. So that means flying to the green regions, the 5 and the 10 is the impact measure here, brings you a lower impact, like flying through the red regions, which are 13 or 27, in terms of using an environmental impact metric. This project was started in 2016, and as was spelled out, it finished in 2018, and we are currently also working on a follow-on project. So the main objective was to explore the feasibility of such a concept of integrating such environmental assessment information during the trajectory planning. And in fact, I'm talking about a multi-dimensional and a multi-criteria optimization. This is how you call when you are constructing an objective function, the one which is used in your optimization, which has different components in it. And you have those components, and then of course you have to weight them. Either you disregard it by making a 0 on it, or you put a lot of focus on it by giving it a high weight. In fact, that was a collaborative project, a small consortium led by DLR with colleagues from Envisa, TU Hamburg, Manchester Metropolitan, Delft, and Reading. So how do we generate such environmental change functions? And I'm showing here for the local air quality, we established this kind of source-receptor relationship. So we give an emission and we follow it. How does it reach the ground? How does it impact the air quality? And this is based on a dispersion modeling and chemical transformation modeling. And you see how emissions get transported and transformed. These simulations were performed with a tool provided by Eurocontrol, also from Envisa. And this is kind of a tool which allows you to use the metrology and to use the setup of the airport. And you can generate then for a specific airport the associated function. So how does it look like? In fact, you have the dispersion model. You have the environmental impact of a certain unit emission, and you put it on the ground. And then you see, where do the people live? Where do people live? Who gets impacted by this kind of fresh exhaust? Who is suffering from the decrease in air quality? And by combining those two values, by having the amount of decrease of air quality and the amount of people impacted, you can have a total measure of what the impact of an emission release at a specific situation is. What you see here clearly is, of course, that the wind is advecting the air pollution to a certain direction, according to the prevailing wind situation. It was the same in Hamburg and Madrid on that specific day. And in fact, while the emissions are advected here, you see, if you weighted with the population being exposed to it, it shows you that it's here to the northwest where the zones of large impact are, because the pollution is transported to the places where people live. And by combining such information, we can provide a three-dimensional, or, because it depends on the metrology, on the day, on the date of the day, because of the vertical layers, because of the temperature profile of the atmosphere, which will determine the transport processes, you have a four-dimensional function, which is this kind of environmental change function. We did the same for noise. Also, I just want to mention a bit, let's say, what is the lesson learned, because noise is much more complex than local air quality, because you cannot simply emit a kilogram of a certain species. You have to know what is the aircraft, you have to know the engine, you have to know what are the flaps and so on. So you have to make it much more complex. The input data is much more multidimensional, and you also have to have a noise metric which works. So what is the noise metric you're going to be using? Of course, noise is also an issue for the operational and safety standards. And for the noise, there's also a tricky thing. There's not only a noise level, which is kind of physics, but there is also the question of the annoyance of it. So here is a kind of challenge identified to define such a metric, which allows us to use the same concept to see, okay, emit at a certain point means like annoyance, a lot of annoyance generated. However, we felt that having such noise ECFs available will identify to enable such favorable trajectories according to the metrology and identify the favorable trajectory. So what we then did, after having constructed these ECFs for airport, we were doing a one-day case study, and we were exploring a city pair by flying from Hamburg to Madrid, and we did a trajectory optimization by flying out of the departure airport and then up to a certain flight level, while then flying again into our destination airport. And we did this by comparing always to the fuel minimal solution. To see to what extent an environmental optimization is changing your trajectory. And what is shown here from our feasibility study, that was for this city pair. In fact, here is shown, this is the altitude, and with the color coding, we are showing here the local the ECF function. So that means if you have white, there is no impact. If you have red, there is high impacts. So what you see here, it's a bit tricky to see, but there are gradients also in here. So what you see here, if you go for the takeoff, we have a trajectory which is in the beginning, which is the initial trajectory. And when you then try to mitigate, to avoid the highly sensible areas, you are moving your trajectory further up in terms of higher altitudes. And in order to measure what is the impact of our changes in the trajectory, we are showing on the one hand side to what extent we change the impacted population, to what extent we do benefit in terms of the environmental impact, while at the same time there is a certain fuel penalty on it. So the early solutions are the most efficient one because they gain the most with a small increase, while here that would be a very inefficient option to go for that one. And in fact, by combining both effects, you get these Pareto fronts as a kind of three-dimensional figure where you can then aim for optimizing both. In our feasibility study, we focused only on the NOx. From a conceptual point of view, it can be done in the same way for soot and particle emissions, because they might also have a very considerable impact also in the different segments. And in fact, just a brief mentioning of the approach. In the approach, we felt there was much less potential for improvement. So you see that there is much less possibility for reducing the impact of the air quality degradation at ground level. So during this project, we identified really research needs on the environmental change functions, and we felt it would be really helpful to also see how does it look like if you do it for the European airspace, and if you really explore this concept further, and also to see what is happening on a kind of full European scale application. The ACCS concept. I have to mention that, and I want to highlight this. In fact, we are talking about atmospheric measures and atmospheric behavior. So there is uncertainty with it because everybody knows there's a predictability, what's the uncertainty to it, and so on. So what is required here are really robust measures. We have to provide robust solutions because it's important if you fly an alternative trajectory, you want to make sure that you're doing something better. Okay, so that's the question of the robustness. And this one is further explored in a follow-on project, which is called Fly ATM4E, which is dealing in the uncertainty of the weather forecast, the environmental impact, also in terms of climate change of aviation. There is all the IPCC debate going on, but also the exact knowledge on the routing. So just to close my overview, I also want to give you a bit more of a flavor on the ongoing research projects, which are still dealing with these aspects. So the first one I already mentioned is this robustness criteria. And we will be targeting on identifying situation which is win-win, which means win for the cost and win for the environment if you compare to the real world. Okay, so where are inefficiencies which can be exploited? The cherry picking strategy will be focusing on routes which have a very large mitigation potential. And this is mainly driven by an atmospheric condition, by some kind of typical situation. I mean, I always take the non-CO2 effects is a contrail, is a typical effect which only occurs on certain days. So in some days, there is the contrail formation very strong. And on such days, you can mitigate the non-CO2 effect by avoiding these. And this is the strategy of identifying beforehand these favorable and high potential situations and trajectories. So this one is led by the Institute of Atmospheric Physics, by us. There is another project which is more focusing on the TMA. So they are exploring the topic in the TMA area in terms of environmental friendly and more predictable flight profiles dealing with emissions and noise. So that's also a project which is in the ER4 program. So they just started this year. And I want to also mention two research projects because this is the point. We are doing a very, very close relationship to the research on the atmospheric side. We are understanding ourselves as an interface, but there's also other projects which focus on improving the knowledge of the mechanisms that lead to the aviation climate impact, and they are intending to reduce the uncertainty and to improve the understanding of these effects. This project is led by a colleague in our house, And there is another project which is dealing with operational improvement, which is the CLIMOP project, which is also aiming for having routing strategies. But there are all websites and you can have information on them. So with this, I want to thank you for your attention and available for questions. Thank you.
Thank you very much, Sigrun, for the very interesting presentation. We do have a few questions, but I mean, quite a few questions, but I rather you can just read them on the side. Feel free if you want to start typing away. We need to get on, and then we'll get back to the questions at the end. Okay, our next presenter is going to be Giuseppe Pilironi. Giuseppe, can you come on stage, please?
Yes, hello. I think Dirk will go first. Sorry, Olivia.
All right. Then Dirk, come on stage then. I misunderstood that.
Thank you very much. Last minute changes, as we know in airline and business.
All right, then everything okay. Dirk has been working on airport operations for over 15 years. He started his Schiphol career in 2012 as an apron controller, and he followed that by positions as capacity manager and service owner for towing and pushback operations. And he is currently responsible for sustainable taxiing for the Royal Schiphol Group. That's why he's here today, to talk to us about sustainable taxiing. And he has worked on this since 2017. And they have done the first trials with TaxiBot in 2020, for which he is the project lead.
Correct, Olivia.
Dirk, the floor is yours.
Thank you very much for giving me the floor. I will take the opportunity to tell you something about the sustainable taxiing trials and way forward that we have at Amsterdam Airport. And in order to bridge the gap between science and operations, that was really the purpose of the operational test that we did. But I'd like to take the opportunity to get you back in where it all started for us, at least, because it all starts with sustainability, obviously. And in line with the Paris Agreement in the Netherlands, the aviation sector established the sector program Slim en Duurzaam, which is the Smart and Sustainable Action Program, by amongst our national ANSP, LVNL, KLM, and Schiphol, and many others. But the primary goal of this sector program is to decrease the emissions with 35% by 2030. And as an airport, we took the responsibility to even, to further set our goals towards zero emission ground operations. It's highly ambitious, but it is our ambition, and I'll be proud to be able to work on this ambition. And obviously, a potential important way is to sustainable taxiing, because this is one of the means of climate impact. Or on the ground, it is kind of the largest impact on emissions. Before I get into the details of the operational test, I'll take you back to actually all available possibilities for sustainable taxiing, because we do see a lot of inventions, but not everything is coming into practice that much. And this is one of the reasons that Giuseppe and I switched our positions in the presentation, because the second to, or the third to right column says all about single engine taxiing. From an airline perspective, it is kind of the holy grail, or the way to go forward from airline in order to have, in a current environment, in a current aircraft, to set the goals towards single engine taxiing. And Giuseppe will talk about that later on in this presentation. And what we did as an airport, we do think we have a responsibility in airport-based systems. Because if an airline, we're welcoming airlines with all kinds of solutions at the airport, and we are working towards rules and regulations, having single engine taxiing as a standard, but it's not as easy as it looks. And in the same time, there are ideas of implementing electrical engines within an aircraft gear, whether it's a nose gear with the wheel tug or a main gear with the Safran Airbus solution. but they will still be propelled by the APU of an aircraft. So there will still be some emissions. And apart from that, they will add on weight and complexity to an aircraft's undercarriage, which I think I do not have to explain what that will do with the in-flight performance and sustainability gains. And this is actually why, in order to move forward and take our responsibility as an airport, we chose to move ahead with the current TaxiBot, as it is currently the only certified solution in sustainable taxiing as well. So that is that for now. I'll show a small video regarding the topic, in which I explain a little bit more about the features of TaxiBot.
We hebben hier op Schiphol een nieuw en innovatief voertuig, de TaxiBot, waarmee we een proef aan het uitvoeren zijn om vliegtuigen duurzaam te kunnen laten taxiën. En dat wil zoveel zeggen als dat we vliegtuigen van de gate naar de startbaan kunnen brengen zonder het gebruik van hun eigen vliegtuigmotoren. Een normale pushback trekker koppelt los na de zogenaamde pushback, het achteruitduwen van een vliegtuig. Dit voertuig blijft aangekoppeld staan tot een positie zo dicht mogelijk bij de startbaan, zodat een vliegtuig zijn motoren op zo'n laat mogelijk moment in het proces kan starten. We besparen tijdens het proces van gate naar startbaan 50 tot 85% brandstof en daarmee wordt de uitstoot ook gereduceerd. Dit voertuig kan, ten opzichte van een normale pushback trekker die maar tweewielbesturing heeft, met zijn vierwielige besturing zowel om zijn as draaien als zijwaarts rijden. Dit zorgt ervoor dat de piloot vanuit de cockpit kan sturen met zijn neuswiel, waarmee de bewegingen volledig worden gekopieerd naar de bewegingen die dit apparaat uitvoert. Taxiën gaat vrij snel. In de luchtvaart spreken we van knopen. Dat zijn 22 knopen. Dat is een krappe 50 km per uur. Het is nu nog een proef, maar we hopen uiteindelijk dat we in de operatie op Schiphol het proces met een dergelijk voertuig ook grootschalig kunnen gaan toepassen.
Well, it should have said it all. In the same time, I see that not everybody has been able to watch the video. We can send a link later on as well after the presentation, obviously. And this gives me, at the same time, the opportunity to introduce my colleague Simon Prent, along with whom I'll be working on this project for 3 years, like Olivia mentioned. Actually, he is in the call to answer any questions regarding this topic. So please feel free, and he'll be able to to answer you live. I hope, at least. So, like mentioned, this was for us the reasoning that we have to go. Well, once we want to go forward with sustainable taxiing, TaxiBot is for us the way forward, and this is what we did. And we took the responsibility once again, and we started a proof of concept, which started in March. Together, you see it in the picture already, with kind of few parties. Makes it a complex and complicated process. But I can tell you from a proud perspective as well that we've been able to perform missions with 3 airlines, with KLM, Transavia, Dutch Airlines, and Corendon Dutch Airlines, along with 2 ground handlers. And in these challenging times, it felt really good to be able to participate proactively and actively in an operational environment. Due to this crisis, we could only manage to have 8 live flights, like it's called. There just were not enough live flights available with trained crew, unfortunately. But in the meantime, we have been able to perform 170 missions, and that goes from dark missions in terms of what is the captain or the pilot flying and the pilot monitoring, what are they able to see on the taxiways. We did de-icing tests, and along with the previous presenter, about sound missions, we have been able to see the sound profile together with the TU Delft of taxibot missions, but also of towing traffic and also of live flights, so of taxiing aircraft. And all in all, this comes up to the potential savings of between 50 and 70% of fuel spent on ground, which is a tremendous amount of fuel, obviously. Although it's a small relatively to what we burn in the air. From a ground perspective, this is basically, for us, really feels like an optimum that we can achieve. But this is when every aircraft on ground would be taxi-botted. And you see the emissions, the local emissions will benefit tremendously. But that, once again, is in the ideal situation that we could taxi-bot all aircraft. And from an ATC perspective, we go to this slide, which, well, I think the image says it all. We performed a fast time simulation, and you might be able to see the red dots on your screen. And those are representing aircraft waiting for a taxi-botted aircraft to uncouple on an active taxiway, and so impacting the flow tremendously. And it is in the current operational concept. And this is what we've seen during the test as well. Obviously, there was not as much traffic as it used to be. We planned, therefore, to taxibot on Schiphol Airport, which is a complex airport with 500,000 movements usually. So we were able, or we wanted to be able to see what a taxibotting aircraft within this complex and busy environment would perform. But now we do have some future plans to see this well when traffic is increasing again. But from ATC perspective, from ground control perspective, in Amsterdam we work. The ground controller is responsible for pushback clearance up till taxiway and lining up the runway up till then. So what we did see is the shift in focus, which is needed in order to implement taxibot procedures on a large scale. It is kind of shifting the focus of a ground controller. Whereas normally, like I mentioned in the video, the pushback truck disconnects after pushback. In his mental picture, a ground controller can block the bay and focus on the flowing traffic on the taxiways, whereas in the situation with taxibot, we were disconnecting on active taxiways as well. Well, I think all professionals in this area, I can imagine what the impact of the flow is, and the simulation just tells you what it will be. It will be a mess in the current situation, and therefore, we do have some remote de-icing pads available and our furthest runway available, which is the 36 left with an average taxi time of around 16 minutes. And there we have out of flow disconnecting points. And that is ideal in terms of uncoupling and flow. But then we do, as an airport, face some difficulties in return movements of empty taxibots, because the service roads were not built for taxibots specifically, obviously. So the width is challenging, but those are challenges that could be mitigated. Then we have some technical challenges on the taxibot itself. The uncoupling time, you can imagine what that the impact on the flow would decrease when uncoupling time would decrease. And there is the procedural mitigations possible, and that is a changed way of working for a ground controller. Because as an airport, we have a lot of positions on our apron ramps, and they are blocked, and I think the French call it the cul-de-sac, by pushed back aircraft. They will block the apron until the aircraft is released for taxiing out. And even with the newer aircraft engines and the newer generations, the geared turbofans, for example, with the longer startup times of these engines, this potential flow, or actually problem coming towards or coming from stands could increase in the near future. So these are actually, from ATC perspective, our main observations and the potential mitigations. Now, what we did, I mentioned before, we tried to bridge the gap between science and operations. So I just showed some very operational stuff. I could talk ages about bypass pins, which will not be there anymore while taxi-botting, but let's not do that. Because from the beginning of our project, Simon and I had in mind that we want to balance capacity, safety, and environment. Because obviously it's a trade-off all times, within the air, but also on ground. So in the right column, in our our individual roadmap from an airport perspective, we've seen from sustainability perspective, we've seen the Paris Agreement as where we want to work on. And that goes up from on a micro level towards the tactical plan of our infrastructure builders, so to say. And that all comes together. But this is just the roadmap which we see necessary in order to move forward on all different fields. Because apart from only sustainability, we do see ample of chances in integrating a vision of ASM GCS on routing, on planning, on guidance, with this option that a towing of aircraft towards runways might give us. But then we're not there yet. And this is where, locally, where we as an airport come to play, but in Europe, where you guys come to play, because this is how we do see that we have to collaborate for the future. I give a few examples, and then I'll leave the floor to the next speaker. I just give a few examples of what has been needed. The potential of taxi-botting by only using a computer-based training for pilots, for the cockpit crew, that is there. Actually, all three airlines have confirmed that this theoretical exercise should be enough for pilots to be able to perform taxi-bot missions on an airport. So that's a very good thing. Although the CBT, the computer-based training, is still an airport-specific CBT, whereas we are obviously looking for more standardizations. In terms of rules and regulations, you can imagine, and once again, that's a very practical example, but the rules of the right-of-way, for example, in Amsterdam, towing traffic always has to give way to taxiing traffic. But now the interesting thing comes to play is that visually a taxi-bot is a a taxi-botting aircraft is a towed aircraft, but formally it's a taxiing aircraft. So it does something with these rights of ways. So it is really needing for standard operating procedures. And from pilot perspective, for example, the before taxi checklist should be revised because no need for engines, but there is need for APU, for example. So there is a huge demand in our perspective for not having a Schiphol specific solution, but having a wider solution. And from ANSP perspective, I could foresee that the same questions arise. How would you be able to deal with the challenges that this process will face? And this is where I would love to take the opportunity to see this need for collaboration in this perspective, but also feel free to contact Simon and me anytime if you want to exchange knowledge and expertise. And for me, that was it for now, and thank you very much for your attention.
Thank you very much, Dirk. So that was it for taxi bots and towing. Now we're going to look at a different aspect of green taxiing, not as green, but halfway there. And for that, we have Giuseppe Pilirone from Air France. Giuseppe has a degree in computer science, and he has worked at Air France for, and listen, it's 19 years and 364 days. So tomorrow will be his 20th year anniversary at Air France. He started his career at Air France in the information technology department, contributing to different business domains such as flight schedules, operations control, airport turnaround management. And his first involvement in SESAR was in the field of the swim information exchanges as of the early swimsuit prototypes. And now since 2017, he is the project manager on different SESAR initiatives where France contributes to. And that is part of the Air France flight operations team of ATM and CNS strategy. Giuseppe, please.
Thanks, Olivia. So Let me see. There we go. I will also start by reminding how much the reduction of environmental impact is a top priority for all actors in the aviation industry, including airlines. This effort has started already for some time, and I picked a few key figures that show a few achievements already reached by the Air France group. Of course, similar steps are taken by all the major actors in the aviation industry. But these results, the big wins come, of course, from new generation aircraft and engines. But quick wins are possible as well, and SESAR shows it that besides technology, innovation, of course, sometimes if you have a smarter look to certain operational practices, this may open up some possibilities. And that's the case in flight operations, where all phases of the flight are looked at for improvements. And this includes the airport, which is the focus of the webinars today. So I will illustrate one specific track of possible reduction of emissions, which is the single engine taxiing, which is, I will try to give a kind of a pragmatic approach in complement, in fact, on what has been shown about taxi. Taxiing is, of course, the movement between the gate and the runway is comparatively short of all phases of a flight. But of course, it is not optimal because it is performed with by using on the ground turbine engines that are designed and optimized for flying and not for the ground. So of course, it's a good idea to keep the time when the engines are running on the ground limited to the minimum necessary time. And several results have already been obtained on this approach. For example, with airport CDM that really optimizes the taxiing times, or with optimized use of the APU. But one idea is also to not use the entire set of the engines of the aircraft during ground movements, because it turns out that a single engine can be actually sufficient to move the aircraft. I will call it single engine. It is sometimes called engine off. I use single engine because to make the distinction between all engines off, which is actually towing or taxibot, or one engine off. Now, single engine is also not completely correct, because you may have 4-engine aircraft where you're running on 3 or 2 engines and so on. So anyway, think of it as any partial use of the set of engines of the aircraft during taxi. An important distinction is between taxi out at the departure from the gate towards takeoff, and taxiing in after landing, so from the runway towards the gate. We will see in a moment that these are different, and inbound taxiing after arrival is actually a little bit easier because you're already moving and you just are slowing down. So on arrival, it's actually already a quite frequent practice, whereas on departure, there's still some improvement that could be found. So that will be more my focus. Okay, so what can we hope to achieve in terms of gains from this kind of procedures? Now, I don't have specific field measurements that we have performed at Air France. We don't have those yet. But basically, the important element I want to bring up with this slide is that you cannot taxi with a single engine all the time. We will see in the next slide that there are important safety conditions that oblige you in certain phases of flight or in certain circumstances to use all of your engines. By the way, this is also the case for taxibot, where warm-up has been mentioned. And in the table here, I address specifically this technical prerequisite about the engine's temperature. Of course, after landing, you need a time of gradual cool down for the engine before you can totally shut it off. And similarly, an engine needs to warm up before applying full thrust at takeoff. These warm up and cool down times are of the order of a few minutes. Now, it's quite variable, and here too there might be an effect of especially on takeoff. Different ways to do the warm-up may give then different environmental performances when you apply full thrust. But basically, it's measured in a few minutes. And it turns out that the taxi times, they're a little variable, but they are usually more minutes than what you need for the engines. Nevertheless, roughly speaking, if you say that you can run on half of your engine for half of your taxiing, that gives you an expected reduction of like 20–30%. So it may seem like a small improvement because it's measured, as you see here, it's measured in kilograms per minute. So kilograms is not very much, but of course, keep in mind that this can be applied on very many flights. And a small measure of a few kilograms on thousands of flights becomes tons. And of course, we know the numbers. An airline group like Air France in normal times operates a number of flights that is in the 1,000 range on one day in normal times. Okay, well, here we see a few statistics about observed taxi times. This comes from the CODA database at Eurocontrol. This shows basically that, well, that there are enough minutes for the thermal prerequisites of the engines. Well, the picture shows kind of the middle line, if you follow it, is the median. Then there's the 10th and 90th percentile. There is enough because the medians are all above those minutes needed for the engines. We can also see that taxi out tends to be longer than taxi in, and that there is a certain variability. And we will see later that this is a crucial point. In this example, the distance between the 10th and 80th percentile is spread over 13 minutes. So we will come to this later. But as I said, there are several safety prerequisites. We mentioned the engine warm-up and cool-down time. Other things to consider are that the acceleration performance is lower, and the thrust is not symmetric when it's applied from one engine only. So this cannot be used if there are turns or slopes or a runway crossing, and it cannot be used in certain weather conditions. But an important safety aspect is the workload for the pilots, because of course, the procedure with single engine taxiing is of course different from the normal procedure with all engines on. But it turns out that the additional workload is bigger for taxi out at departure than it is for an early shutdown of the engine. Basically, again, it is more tricky to start up an engine from cold than it is to shut one down when it's already moving. This is an illustration from the crew operating manual that shows highlighted in red the steps that are specific to single engine taxi out. And as you see, there are they apply both to the pilot flying, monitoring, and to some checklists. So in fact, for this reason, the decision making for taxi out, deciding whether to apply it or not, is a little more delicate than for taxi in. And in fact, single engine taxi out is not recommended by many airlines. We can estimate that on arrivals, this is widely used. Something like half of all flights apply this, and half of all flights is probably all the cases where it would be that actually qualify in terms of safety. Whereas again, it is still very infrequent on departure. So this is an area where there could be a possibility of looking for improvements. Okay, if we look at what the challenges are and what needs to be verified in order to encourage to do departure single-engine taxi more often, it turns out from early investigations with our pilots that one important discouraging factor is this uncertainty, in fact, about the exact available time between leaving the gate and having to put full thrust for takeoff. The taxi times are given, of course, to the pilots as part of the operational flight plan, but these are statistical times because this information is delivered more than half hour before departure. So when leaving the gate, the real conditions at the airport at that moment, like the level of congestion, the waiting queue at the runway, can really make the difference in that uncertainty that we mentioned. And they could, this information might make the difference in favor or against going for single-engine taxi. Because again, the decision must be made at the gate. If you don't start it, it's not started there. So you have the other procedure. So of course, this information of another thing, having the exact evaluation of how many minutes are available will also allow to optimize it at best. Of course, avoiding to start up the second engine too late, which could cause delay in the departure sequence, but also not too early, so to take maximum benefit from the emission reduction. Now, of course, the information about accurate taxiing times is available on the ground side, especially on platforms where systems like Departure Manager or Airport CDM are in place. So basically, all we need to do is fetch this information and make it available to the cockpit. And these days, of course, getting the information from a system and pushing it to the crew is supposed to be easy. But here again, there are several points of attention about how to do this at best. First of all, from which system, which is the system from which best to retrieve an accurate estimate. It could be an ATC system, it could be CDM, but it could be some kind of smart predictive model done by the company. In fact, I think there has been some experiments by British Airways at Heathrow that were just pushing the target takeoff time, the TTOT, to the crew. So that's an experience that would be interesting to fetch. But the TTOT is not always reliable on all platforms because some further optimization might be done outside of the TTOT. Some platforms have the habit of using estimated taxi out times. And of course, CDM is not in place everywhere. So this is really an area where work with, I called it here the airport CDM community. So all the actors of the airport platform is where the work should be done to find this small detail, how to get the best estimate. By the way, it's not necessarily having the very exact estimate. What is necessary is a reliable minimum number of minutes, because of course that would reduce the optimization, but at least it wouldn't put the engines in danger and introduce more detail. And then, of course, the other point, which is not necessarily how can we say, it might present some challenges, is also what is the best way to send the information to the cockpit. But this can be accommodated depending on equipment available and local habits. So yeah, in conclusion, Voilà, this was just a quick overview to see that, again, every measure is good to take. All possibilities are being looked at, but safety comes first, of course. So again, what we try to do is to make simple ideas, to refine them and try them to make them happy, to make them happen. But of course, we always have to check if a quick win is really quick and if it is really a win. That's all for this presentation. Thanks for your attention.
Thank you very much, Giuseppe, for your presentation on the single engine taxi. That's really interesting. We have a lot of questions coming up. You may have taken note of some, but you may want to take a look yourself. We're a little bit running late, so I'll just go straight into Annika's presentation. Annika Poll is our last presenter today. She is also part of the SESAR Exploratory Research community. She actually graduated in spatial transport and environmental economics from the University of Amsterdam. And she has been a researcher in the Bauhaus Luftfahrt since the year 2010. And she has been there the lead in projects analyzing future passenger travel behavior. Her PhD is from the University of Dresden in 2018. And her dissertation is actually on the constraints for market power in European hub airports, very, very relevant topic for today. And she is actually leading a SESAR Exploratory Research project investigating intermodality and multimodality aspects affecting air traffic management. Annika, the floor is yours.
Thank you, Olivia. Very nice to be here, and I would like to take you on a multimodal journey today to understand the role of environmental aspects and the impact on aviation. So first of all, the important questions in this regard: why is it important to consider and integrate multimodal aspects in future air transport planning? And what is the role of environmental factors in future passenger behavior? And when we talk about intermodality and multimodality, these terms are most often used in the same way. And one way to describe it is that passengers, when you do a trip, you can use different transport modes. For example, you can take the train or you can take the plane to get to your vacation destination, for example. So you're choosing between two different transport modes. On the other hand, it also denotes the concept where you conduct trip chaining, for example. So you have different means of transport that you align with each other. So you're using, for example, the bus to get to the airport to do your trip to go on vacation. And what is important in intermodal transport now is to consider the entire door-to-door journey, like you can see at the top here, where you have different segments. For example, if you use air traveling as one segment, you have to get to the airport, then you're traveling within the airport, and you have to reach your final destination as well. And one of the European transport goals in this area is to enable passengers to shorten this time. It has been set to 4 hours. So this is what you see at the bottom, that transport planners and policymakers want to achieve a significant reduction in travel time for passengers. And therefore, it's important to consider all these different steps in a combined trip analysis. When we talk about environmental aspects and bringing these different things together, it is interesting and important to think about how can environmental awareness and regulations affect air transport. And what we've seen in the past years is a change in awareness, but also new regulations coming up. And this might lead to passengers compensating their flights, compensating maybe their entire trip. Some of them are substituting away from air travel or not traveling at all, or they're substituting particular trips, for example, on the short haul. So this is interesting and important to consider when thinking about what is the role of intermodal travel, what is the role of other transport modes, and how is it affecting air travel. And what we see on the passenger side, or what we have been observing in the past years, as I said, is that increasing environmental awareness. However, this awareness does not necessarily translate into actions. So everyone that is thinking about choosing a different transport mode, or maybe even in other areas doing something to reduce their footprint, does not necessarily mean that they act upon it. So this is something that we've been observing in the past, but this behavior is also changing, that people are taking steps to translate that into action. And we've seen different social trends, different paths in the society pushing for stricter regulations in different areas to actually reduce the environmental footprint of very different areas, but of air transport in particular. And going along with that is that a so far limited awareness could be observed, but this is also changing. Passengers are aware, okay, if I'm going on a long distance trip, what are the emissions that go along with that? Do I really want to do that? Do I want to compensate my trip? And this is what you see here, the willingness to pay for example, carbon offsetting of passengers is also increasing, but it differs very strongly across regions. So these are trends in behavior that we're seeing, that we're observing, which can actually have a significant effect on air travel. And it does so by changing the perception of travelers. And here, for example, you see an example from a different project that is already finished. We have one passenger, or we named one passenger group environmental traveler. So a traveler which places particular emphasis on environmental aspects and chooses the trip very carefully, calculates emissions, and maybe even compensates for all the emissions that arise along this particular trip. And also recent surveys, as you can see on the right-hand side, have shown that within a year, more passengers are willing or are thinking about to travel less often by plane or to fly less. And you can see in the EU, the change, or the number of passengers changed from 11% in 2018 to more than 60% in 2019. So this is a significant change we're seeing here. And as I said before, the question is this perception, this awareness, this willingness actually translating into actions? And it's not just flying less, but as you can see on the right-hand side, that people want to use carbon offsetting schemes, for example. This is the light blue one, in a higher dimension than they've done before in all these different world regions. So there are different trends going along that you can see how passengers will change their behavior by themselves, being, for example, intrinsically motivated and say, okay, I want to reduce my personal footprint and therefore I might be flying less. I might not go on this long distance journey, but I might prefer one destination which is close by and which I can get to by train, for example. So this is something that we've been observing to increase a lot over the past years, and it will be interesting to see if we go out the current crisis, how this behavior will sustain, whether it will strengthen in particular areas for particular passengers, and how this also we translated or enforced by governments, for example, by introducing different incentives or regulation to steer the use of particular transport modes in a certain way, for example. And in terms of passengers, this might mean introducing compensation schemes, which they have to follow, or there have been discussions in the past of everyone having an overall carbon budget, for example. I mean, there's a lot of pro and cons and a lot of discussion going on. Just want to highlight some examples in the direction this might actually go. And passengers now being able able to compare trips in regard to the CO2 emissions that are being emitted gives a whole new field of comparison, for example. And also operators, they're facing a lot of regulations coming into place, like offsetting, emission trading, carbon taxes. So all different areas being touched, therefore also being incentivized to introduce innovations, new technologies in order to reduce the footprint of their fleet, for example. And what we've heard before are good examples of that, good approaches that are being done in all these different areas to actually reduce the footprint of aviation as a total. And what we see on the passenger side is that the industry, of course, is reacting to that as well. And a passenger who's very environmentally aware and wants to offset their emissions and wants to plan their journey accordingly does get more opportunities now. And one effect that what we might see, as I said earlier, is that routes and stage length, for example, are changing, and passengers are very carefully checking not only prices and maybe flight times, the best or the most convenient one, but they're also checking the least CO2 emissions options. And what you can see here on the right-hand side, unfortunately, it's only in German, a German platform where you can click, for example, the cheapest option, you can choose the best option, and the one where you see the circle is the option with the least CO2 emissions. And this is what you see here, for example. I chose a flight from Munich Airport to Los Angeles, and there you can see different prices for 2 providers. So passengers can actually incorporate this option now when choosing their flight. And the question will be, if it's very or much more expensive than the flight which actually emits more, or the travel chain which emits more, are passengers really willing to pay for this? How much more are they actually willing to pay? So these are questions that are currently being investigated, but it will definitely have an effect on the future air transportation system, the network we're seeing, and how this is being composed. And another change that it can be fostered by that is the introduction of the most efficient aircraft types into the fleet of airlines. And we're seeing some developments at the moment, which types of aircraft are being employed, discussions in the airline industry, how the positioning is going on after or going out of the COVID-19 crisis. So this will be very interesting how the future fleet composition will look like and how the effect on capacities, for example, will be. And another important point, what I said in the beginning, when looking at intermodal transport options, how do people get to the airport? Which segment of their journey are they covering with which mode? For example, people going on a long distance trip might be using the train more to access the airport, might be using the bus instead of these short-haul feeder flights, which are being offered by airlines at their hub airports. So this is a change which we are anticipating in these different areas, which can actually have a significant effect on the different key performance areas which we're seeing in the ATM system. And one very interesting one and that we're looking at, and what I talked about, is the changing fleet composition and aircraft mix that we might be looking at. As I said in the beginning, people might be moving away from short-haul air traffic, replacing that with a train journey, and that might mean, just hypothetically speaking, that we see less aircraft serving these short-haul routes, and that might be replaced with larger aircraft, for example, heavier aircraft. So, and that would imply that we have or might have reduced runway capacity due to larger wake separation minima. And but also maybe less capacities at the gate due to larger aircraft being parked, different requirements in regard to turnaround due to ground handling that is required for these specific aircraft. So the composition of the fleet at a particular airport might change to changing traveler behavior, to switching to other modes on a particular stage length. So this is something to consider for future ATM planning and to take into consideration. Also, as I said, with regulations, incentives being in place, we might see actual restrictions that particular aircraft are not being allowed. They have to pay very high fees or taxes at an airport, so thus influencing, incentivizing the change in fleet structure as well. And what is important here, and from the analysis of passenger behavior and what we see in connection with other transport modes, that and also, of course, with the current pandemic, that we cannot assume demand to just grow and keep up where it's left, but that we very carefully have to consider the composition of this demand. So what type of passengers are actually flying? What are their requirements? How does it affect the demand for particular routes? And how is this affecting the network and in turn the fleet composition, for example, which we see at airports? And one step towards analyzing that is our SESAR Horizon 2020 funded MODUS project, which Olivia mentioned as well, which started this year, and in which we're looking at the performance of the overall transport system, considering the door-to-door journey, in order to give an assessment about the role of air transport within an integrated intermodal European transport system. And we're doing that by looking at drivers for passenger demand and supply of mobility. So one part which you saw today, how is, for example, this increasing environmental awareness changing the demand for a particular transport mode? And then using that in our modeling exercises to model the allocation of demand across different transport modes and to investigate the effects on overall capacity, and being able to give a statement about how future air transport capacities, for example, might be affected if we see a very strong shift on short-haul markets to the rail sector, for example. And we're doing that by taking into consideration different performance and connectivity indicators in order to identify the gaps that we're seeing today and give recommendations how to move forward. The project started this year, and if you want to get engaged or if you want to learn more about MODUS, we're very happy if you visit our website. So be welcome, or just send me an email and learn more about what we're doing, about the results that we're working on, or maybe get engaged yourself by providing insights, exchanging with our different partners that you can see here. So we're very happy to move forward on this. So thanks a lot. Happy to answer questions and engage further. Thank you.
Thank you very much, Annika. That was very interesting. It's interesting that we have been hearing about this for a long time, but it's been very hard, I think, for us, the aviation community, that's, I think, very closed, to understand how eventually we cannot turn our back on this. We really need to engage and understand how it's going to affect the future environment of aviation, which is what we want to improve. We are a little bit late, but we do have time for some questions. First of all, I'd like to say that we do have a polls next to the questions. There's a polls tab, and so a poll has been launched, or is about to be launched, with the satisfaction. So please go ahead and answer that anytime, as soon as it's launched, of course. And you know, can I ask all the speakers to come on stage now? Thank you, Giuseppe. So we have many questions. I've tried to make, you know, we have very little time. I've seen that a lot of questions have been answered in the chat, which is great. I've tried to kind of take a sample of things that could be asked now. First, maybe to both Sigrun and Dirk, that we're talking about the most futuristic aspects. You know, there were questions about how realistic this was in a you know, non-COVID environment where we have so much traffic. So first of all, for Sigrun, do you think that this is realistic, that we will be looking at the environmental cost functions around the airports, and that we can make this actually play as one factor?
I think they can be, at least they should be assessed. Let's be very realistic. At least they should be used in order to assess the impact. That's the first step. And then if you better understand the impacts, you can aim for optimizing and reducing them. I'm very realistic, and we all know that a TMA is really sometimes very, very crowded, and there are a lot of constraints and so on. However, I think the first step is to be able to assess it, and then you can focus on optimizing it, or at least deciding which is the better option. You might be enabled to decide between one and another option to identify the more environmental compatible one. But I fully understand there is high complexity, but I think it's worth integrating the information. Yeah.
Thank you very much, Sigrun. And how about Dirk? Do you think that this is scalable, so you can really have all aircraft taxied with taxi boats? Or a lot of questions about what happens if there's a problem, like one aircraft has an engine problem and they detect that on startup, and then they're blocking the taxiway, they have to turn around, whereas now they would discover that at the gate. I'm sure you've been asked this before.
Definitely, and I don't want to downplay these questions, but if we were not believing it, even this project would not come as fruitful as it was with the airlines, with ATC. The potential is there. And although a lot has to be done, and then I get back to our genuine responsibility, we as an airport, I as a person, and we as a society have to take jointly. And that is to create a sweet spot between safety, capacity, and environment. And in the current operational concept and in the current conditions, I do not see this working personally on a very large scale. But you could foresee example in Amsterdam, you might know our infamous runway as the third runway of Heathrow, the most western runway with the immense taxiing times. We, as an airport, we might be able to isolate this airport for taxi-botting procedures, for example. Not only taxi-bot, but make it possible. But if we do not start this process, we will definitely, the next 50 years would be still the same. And this is my personal, belief, I would say.
Thank you very much, Dirk. Then I would like to invite Giuseppe to put you on the spot. We have had some questions that, we're looking at the practical aspects. One of them, you were mentioning that you need to know the target takeoff time, or at least some available time for the taxi out. Do you need anything else from ATC? Do you, like Dirk was saying, well, we need to sort out for the taxi boat whether the towed vehicle would have preference or not. We have to make an agreement. How about, because the stop and go that sometimes happens is kind of easy, or at least we know how to manage it when all engines are on. But what happens? Does ATC need to help you more? And that's one question. The second question is, can anyone, provided that you mentioned some airports forbid that, if the airport doesn't forbid it, can anyone today, can any airline do this one engine taxi in any airport if they want to, or do they need to seek some certification or approval?
Well, whether the airport prevents it is in the AIP. I mean, that's a known thing. Yeah. So that's yes or no. I know that the single taxi departure is part of the official Airbus flight crew operating manual. So it is certified. I mean, then not all airlines in their internal procedures allow it or not, or encourage it or discourage it. But it is part of the FCOM of the 320 family, at least. That's the one where we have the most. About the other question, indeed, that should be investigated, whether there can be a difference in the taxiing that might impact the surface movements, and in that case, some solution might need to be found. At least giving the awareness to ATC that the procedure is being used. It's indeed an important aspect to address. I was thinking about the safety. I mean, one thing that applies to both procedures is that the pilot doesn't necessarily see what's happening with these engines. So things like I think it's called tailpipe fires and stuff like that. At the gate, of course, there's the ground stuff that takes care of that. I don't know, it wouldn't be ATC, but maybe along the taxiways, there could be a way to cover some of those aspects. It would have to be organized once these practices become more widely used.
All right, thank you very much, Giuseppe. And I think Annika is coming back. Annika? Yeah, you lost connection for a moment. I was you know, the next question is for you. That you know, people have been asking, well, people seem to be more environmentally conscious, but that doesn't really make them choose for the timing a different mode of transport. And do you think that this will arrive, that they actually choose the mode of transport because of the environmental footprint? Or do you always see this as linked to the policies that are taken, so that it will be kind of incentivizing certain modes of transports over others? Or what's your view?
I think it's part. I think there will be a group, as we see now, as I said, like the environmental traveler, as we described that particular group, which will place a very high importance on the emissions of a particular transport mode and how they travel. And we see that particularly developing in younger people also, that they're very conscious of where they travel, of their footprint in total. So I think it will play a more important role and push for incentives of the industry to do more in that area. But I think that also, and that's what I said earlier, the value action gap, that people are still have the opportunity to travel and still want to go to places, learn more about the world, and therefore flying, of course, is the only opportunity to get to these places in a very good time. So there's always be a trade-off that needs to be addressed, and I think that will be interesting how that can be integrated and like things. And I think one question was whether travel on short haul will be prohibited totally. And I think that won't be the approach, because that will be difficult, because some areas, some remote regions, although they might be very close and within a particular stage length, they can only be reached by air travel. So it's difficult to sort of say, okay, we're not doing that in general, but it's creating transparency, learning more about the emissions. And I think we had a very nice presentation today as well about all the different effects that are associated to that. So it's creating that transparency and giving people the choice. But I don't think that we will have everyone moving away, because air travel still provides a lot of opportunities and connections, and is very important.
Thank you very much, Annika. We are almost out of time, so unfortunately I cannot. I do have a lot more questions here. We can't answer anymore. I would like to give the floor last to Philippe Lene, for any closing remarks he may have. In particular, I know there were some questions about the regulation and how, or anything you may want to say. Please, Philippe. I saw you answering.
Thanks. Yeah, no, I answered very good question, because I think some of the questions were raising the problematic that we want to illustrate today, notably on the fact that some solution might slow down the traffic. Well, that's exactly the choice we have to make, and we might face in the future, is that do we always want to concentrate on the very efficient flow of traffic and always only concentrate on the delay, or do we want to take much more seriously this environmental consideration and then give up on the thing that we have been doing in the past? So that's a fundamental question that we need to ask ourselves. And about the solution, certainly we will not going to find one or several solutions that will solve it all, but the important is to allow to deliver solution that will be scalable and adaptable enough to each particularity. And that's very much the case for the airport question, because the airport, all of them, they have their particularities, and we need to be able to be flexible enough and allow them to take the best of each solution whenever they are able to do it. So if I may say, that was the few points that I take. And one very last point, a word that was Sigrun who indicated this, is robustness, is that everything we deliver. Let's not forget we are here talking about climate change and mitigation on the climate impact from aviation. So everything we propose needs to be robust and really demonstrated that it delivers correctly toward the mitigation of the climate impact from aviation. Voilà, if I may say, and nice to see so many questions and so many people today. And thanks to all of you, thanks to you, Olivia, for this opportunity.
Thank you very much, Philip. Well, thank you very much, everybody, for attending. I already said it at the start, but I'm going to say it again. You can access the presentations and the recording in the SGU events webpage. And we will also publish in a couple of days, probably, the Q&A. So with all the replies that you see here on the side and some more that we have had no time to type now. And please, we look forward to seeing you in our next webinar. And do reply the poll. We love your feedback. Thank you very much. Bye-bye.
Bye-bye.
Well, thanks, guys. It was a pleasure.
Thank you. It was very nice. Bye-bye.